Okay, so today we'll discuss parabolas. Parabolas are a kind of conic, and what a parabola is it's defined as the set of all points in the plane that are a certain distance, or actually are the same distance from a given line called the directrix than they are from a given point called the focus. So all the blue points here on this parabola are the same distance from this point called the focus as they are from this line called the directrix. All right. Now we have a number that we want to define that is kind of what we're going to use to characterize these parabolas. That number is this distance right here. This distance right here between the focus and the vertex. I'm going to call it P. And because the vertex is a point that's on the parabola, that means the distance from the vertex to the directrix, because of the definition, is also P, right? Because all the points on the parabola, all the blue points, are the same distance from this red dot as they are from the green line. So that also holds true for the vertex. I'm calling that specific distance P. All right, now I want to come up with an equation to describe all these blue points. So let's choose an arbitrary blue point. This is going to be the representative for every other blue point. I'm just going to call it xy. X for the x value, y for the y value. We already know that the x and y value of the vertex of a parabola are called h and k respectively. So h and k, hk is the vertex of the parabola, the place where the parabola changes directions. All right? And what we're saying here is that this distance here, let's call it d1, in order for this to fit the definition of a parabola, has to equal this distance here, this vertical distance. Let's call it d2. All right? So in order to come up with the equation of a parabola, what I'm going to do is I'm going to find d1 and d2 and make sure that they equal each other. Well, let's take a look. Let's find some of these ordered pairs here. For instance, the ordered pair for the focus. Well, the ordered pair for the vertex is H, and the focus is directly above the vertex in a parabola that opens upward. All right, so that distance P there is what I have to add to the value of K from the vertex to get the ordered pair that gives me the focus. So the x value for the focus has to be the same. It's the same number h, because it's vertically directly above the vertex, the focus is. The y value for the focus is the y value for the vertex plus this distance p. So it's going to be k, which is the y value for the vertex, plus p. And that is going to be the ordered pair for my focus. The ordered pair for my focus has the same x value as the vertex, h, but the y value is k, this distance here, k, the y value here, k, plus this distance here, which is p, k plus p. All right, so I have the distance d1 from this ordered pair xy to this ordered pair, which is the focus, is equal to this. Let's see, let's say that d1 then, d1 is equal to the square root, the distance formula is what I'm going to use, of x, which is the x value of the ordered pair on the parabola, minus h, which is this x value right here, squared, plus, and then we're going to have, well, it's going to be y, that y value, minus, well, this y value is actually k plus p. So I'm going to put it in parentheses, k plus p, and this whole thing has to be squared. So this is the distance from this arbitrary point on my parabola to the focus, Now what I need is the distance from the arbitrary point on the parabola to the directrix. Well, what I want is I want this line to be perpendicular. so that this distance here is just the difference in the two y values. So all I really need to know is the y value of this point right here on my directrix. Well, let's see here. The value here on the y-axis, the value directly to the left of my directrix, is the value of k, which is above, minus this number p, k minus p. That's that y value there. So the directrix actually has the equation x is equal to k minus p. Oops, not x. Sorry about that. It's a horizontal line, so it's not x equals k minus p. Horizontal lines have the equation. This equation would be y is equal to k minus p. So that's the equation of the directrix. Y equals k minus p. It's a horizontal line that goes through this point right here, 0k minus p. So this point right here, I already know what the y value is. The y value is k minus p. But if you notice, this point right here is directly below this arbitrary point on this parabola. So the x value has to be the same as the x value there. So this is that point on the directrix. I want to know the distance between the arbitrary point xy and this point right here, x comma k minus p. So distance 2 then, let's find distance 2. The second distance is actually just going to be the difference between the two y values, because it's the square root of, well, the two x values are the same, so that's going to be x minus x squared, which is actually 0, and then plus, and then it's going to be y minus k minus p. So it's going to be y minus k minus p in parentheses like this, and this whole thing is going to be squared. All right. So we have our two expressions for these two distances. Distance 1, the distance from the focus to an arbitrary point on the parabola, and distance 2, the distance from the directrix to an arbitrary point on the parabola. And what I'm going to do is I'm going to make sure that these two distances are equal to each other. That's what I want to make sure. So I want d1 to equal d2, because that's the definition of a parabola. It's the set of all points that are the same distance from a given point called the focus and a given line called the directrix. So this is the distance to the focus, this is the distance to the directrix. I want to make sure they're equal. So I want to make sure that the square root of x minus h squared plus y minus k plus p squared, I want to make sure that that's equal to the square root of, well, this is going to be 0, so 0 squared, and then this one is just going to be y minus k minus p whole thing squared. So the square root and the square cancel each other out, telling me that this is just y minus k minus p equal to the square root of x minus h squared plus y minus k plus p squared. All right. So what I want to do to finish solving this, or to finish finding simplification for this, is to square both sides. If I square the left-hand side, it gets rid of the square root, leaving me x minus h squared plus y minus k plus p squared is equal to this thing, y minus k minus p, the whole thing squared. So I squared both sides to get rid of this radical. All right, let's see what I have on the left-hand side. I'm going to square all of these binomials now. I'm just going to FOIL them out. So when I FOIL this one, well, actually, I'm going to keep this one the same. This is the only one I'm going to keep the same. I'm going to FOIL these two. I'm going to leave x minus h the same. X minus h squared But plus, I'm going to FOIL this. So I'm going to multiply y times y to get y squared. I'm going to multiply y times negative k plus p to get negative y times k plus p. I'm going to multiply another negative y times, or y times negative k plus p to get another negative y times k plus p. And I'm going to multiply k plus p times k plus p to get k plus p squared. So I've FOILed that thing squared. I'm going to do the same thing on the right hand side here. So I'm going to multiply y by y to get y squared. I'm going to multiply y times k minus p, or negative k minus p. Oops, not equal. I'm going to multiply y times negative k minus p to get negative y times k minus p. I'm going to do that again to get another negative y times k minus p. And then I'm going to multiply negative k minus p times negative k minus p to get positive k minus p squared. Let me just move this over a little bit so I can fit it all in here. So I have a negative, or negative k minus p times negative k minus p is positive k minus p squared. All right, now let's see what happens here. Okay, so the y squared on the left side, if I subtract y squared here and subtract y squared here, they would both cancel out. Cancel, 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 cancel. Um, let's see what else we have. I can also, oh, that's all I can really do right here. So let's have x minus h squared left over. Those y's just go away. These two are like terms. Negative y times k plus p, negative y times k plus p is negative 2y times k plus p. And then I have this plus k plus p squared. And this is equal to, those cancel, leaving me negative y times k minus p. Negative y times k minus p are also like terms. I get negative 2 y times k minus p. And then a plus k minus p squared. K minus p squared. So now I'm going to just go ahead and distribute everything. I'm going to leave this one the same in anticipation of what the formula is going to look like. But everything else here I'm going to multiply out. This is going to give me negative, well, the x minus h squared stays. But here I'm going to get negative 2ky minus 2py. And here, when I multiply this out, once again, I'm foiling this. I'm going to get k squared plus 2kp, and then plus p squared. I did that one shorthand. I didn't do the entire foiling. I just gave what the answer was going to turn out to be. All right, and then we're going to do the same thing on the right-hand side there. So on the right-hand side, I'm going to distribute. Let's see, I'm going to distribute the negative 2y to get negative 2 ky, and distribute the negative 2y to this to get positive 2py. And then this one, I'm also going to distribute everything out. So I'm going to get k squared minus 2pk, or 2kp, minus 2kp, and then plus p squared, plus p squared. All right, let's see what happens here. I have a negative 2ky and a negative 2ky. If I try to add 2ky to both sides, they'll cancel, plus 2ky. They'll just cancel each other out. So that term doesn't have to be worried about. Let me see here. I have a I have a k squared on this side and a k squared on this side. If I subtract k squared from both sides, those just both cancel out too, k squared. So that would be gone and that would be gone. And let's see what else we have here. A p squared. If I subtract p squared from both sides, subtract p squared from both sides, these would cancel the p squareds out. And let's see what we'd have left over. Left over, we'd have x minus h squared. And then it would be, we'd have this minus 2py and a plus 2 pk, kp, pk, it doesn't really matter. And that's all that would be left on the left side. And on the right side, we'd have a plus 2py and a minus 2pk. That's this term here and this term here. All right, so this is what I have left over. What I'm going to do, this term that I haven't really touched, it still has the square on it. I'm going to leave this term all by itself. That term was special. That's why I left it alone. I'm going to leave the term x minus h squared all by itself. And then I'm going to move this over to the right side. So if I add 2py to both sides here, they'd cancel out on this side, and on the right side I'd have 4py. If I subtract 2pk from both sides, they'd cancel out on the left side, but on the right side I'd have minus 4pk. All right, so what I have here is almost the correct form that I want. I have x minus h squared equal to, and then here I have this common factor in both of these of 4p. 4p, that's very interesting. And what I have left over is I have y minus k. So this is what we call the standard form of a parabola. When you have it in this form, a lot of things become very apparent. Let's bring this up to the top where we can examine it in terms of the geometry that we had up there. Remember, this all came from a bunch of geometry. So let's go back up to the geometry. Here's the equation that we just derived. All right, and let me actually look at this in terms of this equation here. So we just got this equation. X minus h squared plus 4p times y minus k. Well, hk is the vertex of the parabola. Remember that? The vertex of the parabola is what we're calling hk. So this is the vertex. So just by having the equation of the parabola in this form, I can immediately identify the vertex hk. Now from the vertex, this number p is the distance that you go to get to both the focus and to get to the directrix. Now if p is negative, if p is a negative number, it means that the focus is above the vertex, or sorry, the focus is below the vertex and the directrix is above the vertex. If p is positive, it means the focus is above the vertex and the directrix is below the vertex, like this case right here. So on the next video, I'll give you an example of graphing one of these things using this equation. But this is the theory behind graphing it. You're going to identify the vertex as hk. You're going to identify the focus and the directrix based on this number p. And it's all based on this graph right here. And where this equation comes from is actually going through and making sure that the two distances are the same for any point on the parabola. So you choose any point on the parabola, the distance from that point to the focus will be the same as the distance from that point to the directrix. For any one of the points on the parabola, the distance to the focus should be the same as the distance to the directrix. That's how we define the parabola. That's where this logic comes from, and that's how we derived this equation, right here. Okay, so take a look at the next video.